Hey, I'm Mitch. I'm a software developer at Reposit Power, and so we control batteries. You might have heard from my colleague, Dr. Kalman, a few talks ago. And so we make battery control systems, and we tell the battery when to kind of charge and discharge. And today, I'm going to be talking about kind of payment layers, and especially focused on the IoT landscape. And so the title of the talk, 402 payment required. In the status codes for HTTP, you can get a 200 OK, a 500 internal server error, 404 not found. And when I was first looking at these codes, two kind of stood out. I'm a teapot on the hypertext coffee pot protocol, but also the 402 payment required. And when I first saw this, I was really excited, and I'm like, oh, I'm going to get heaps of 402s, and I'm going to be paying for things, and we can pay just like we transfer data. And so there hasn't been a lot of that, I guess, and this has been this thing that people have been trying to implement for a while, that how can you transfer data but then transfer value as well in a single kind of transaction? And so another way you can kind of think of this, rather than 402 and buzzwords and stuff, is like an open protocol for payment over IP would be pretty great. So just like with HTTP, we have this open protocol. It's fast, it's easy to implement. Like, you don't have to download http.exe. Like, you can implement against this protocol, and when you speak the right way, things will listen to you. And so if you're a small IoT device, you can have your own implementation, you can spin up, and you can just start chatting. And if you say the right things to the right places, then people will just talk back. You don't need to sign into things. You don't need to really identify yourself. You can just start transacting in this data layer. So to kind of make a payment protocol like that, you want a lot of the similar things. You want this implementation that anyone can implement against rather than a fixed system. You want to be able to support a wide-ranging amount of value, so very big amounts of money, and ideally very, very, very small amounts of money. When you start thinking about computation and stuff, generally we think of micropayments in kind of like the human sense as like 1 cent or 2 cents. But ideally, if you could get it much, much lower and start paying on the byte or on the CPU cycle at those kind of increments, especially in the IoT space, you start to get some kind of interesting environments that can develop from that. And of course, having it trustless and anonymous is nice because you can just start transacting with people. Just like I can send HTTP and get something back, I don't necessarily need to know exactly everything about the person I'm transacting with. If I can also do that on a value layer, kind of like if I give you cash, we don't necessarily need to trust each other in that kind of sense. And so that makes the transactions a lot easier. And so just for a simple example, let's say you have a smart sprinkler and it has a solar collector on it, and so it knows when to water your garden, and when there's clouds, it won't water your garden. And it's an IoT device, so of course it's connected to the internet, and perhaps a service like FourCast sends it weather predictions, and so now in the morning it can decide whether or not it's going to water the sprinkler based on whether it's going to be cloudy or not. And this is a lot of the time where kind of the IoT space at the moment stops. You have this device that does this one very specific thing, and the rest of the time it kind of sits idle. So the sprinkler, it has a lot of other things going for it. It's this sensor out in the world, and so you might want to kind of aggregate that data. And so there's many sprinklers all around the world. Someone might aggregate the data. Now they don't need to put sensors out there. They can get it from the sprinklers, and perhaps they resell it onto someone else, like BOM, and it doesn't exactly work, I guess I know, and then BOM perhaps could use that data to feed into their weather data that FourCast buys. And you can see in this system that there's kind of this transformation and then sending and transformation and sending. And each player in this system is specialized for their kind of service. So the sprinkler does something that the other services can't do, and that's measure the irradiance at that point. The data aggregator is really good at aggregating, BOM's really good at what they do. And so you can move around this way with the data really easily through HTTP, but if you think about how you can move the other way, like how can we pay for all these services and stuff, like in a perfect world, you would just pay the sprinkler a small amount of money. The sprinkler would pay FourCast a small amount of money, but you kind of can't do that. You have to have these big service agreements and log in and put your payment credentials in and stuff like that. And then further than that, this sprinkler still isn't being perfectly utilized. Like, there's a lot of other things it can do. So let's say you have a big website, and you want to load test it, it's kind of hard to simulate a million devices all pinging you at the same time. It's this weird thing you have to simulate. But this sprinkler can do it, and there's probably a lot of other sprinklers that can do it, and fridges and phones and anything else. And so you can also start doing stuff like ping tests really easy. And maybe the payment layers kind of are really small, right? So like a ping is much less valuable than, say, the FourCast IO service. And so that's less value. So now your sprinkler has to, say, ping 10 websites. Now it can get a little bit of data from FourCast IO, and maybe it can resell its solar data. And so, like, in a macro sense, this totally makes sense. Like, this is just a market. I'm not explaining anything new. But if we can implement this on a data layer, you can start doing a lot of interesting things. For instance, say FourCast IO is under heavy load. Maybe they could have dynamic pricing. And so rather than having to rate limit everyone, they've got this scarce resource they're trying to utilize. Maybe they could just up the price slightly. The ones that need the resource the most will still get it, and the ones that can wait a little bit will wait. And so this is kind of like an excerpt from a really good piece that you should read at the bottom, but it's basically talking about how like HTTP is great, but because you can't do that value layer coming back the other way, it's just very chatty, and so things are just too cheap to meter. And so from this, you get things like DDoS on one end, where everything's too cheap to meter, and on the other end, you get like these very complicated payment systems. And if we want these simple devices, then having to give your credit card information, or let's say give your credit card information to FourCast IO, they give you API keys, you give the API keys to your sprinkler, maybe you got to keep that credit card updated. That's kind of a complicated system. And so like kind of modeling it like at the moment, if FourCast IO's pricing model is if you make less than 1,000 calls a day, you don't pay anything. And it's not, they don't do that because they're like charitable or anything like that. It's just because they're like, we're charging so little per call, like 1/100th of a cent, that we just don't want to meter that. Well, we do want to meter that, sorry, but we can't meter that because it's just too much to kind of work out. But then if you want to do a lot of calls, you have to give your credentials and they'll give you back the data. But also there's so much on top of that. With API keys and sign up and payment processing, and even on their end, they have to settle properly and have to pay Visa, 30 cents plus 3% or whatever deal they have. So ideally, if you could just break it down into this. So you would give payment in a trustless way, and they would say, here's the data back, and then like you're done. And so looking at an implementation like this, this code here actually gets reasonably close to that with, there's a data request on one end with proof of payment, and the data comes back on the other. So this kind of, on the client side, looks like a pretty standard requests .get against a URL. The URL is just the root of a server, and the server is kind of just a standard Flask server, right? And it just returns hello PyCon AU. And so that's the data layer side. The value side is just essentially this. This is a helper library that can you can wrap things. And so what's happening on the client side is the requests channel is getting wrapped to handle a 402. And on the right side, the kind of server is wrapping Flask. And Flask is now able to handle 402s and requests for payments and stuff. So just to quickly break down what's actually going to happen, you're just going to make your standard requests for Slash like you normally do. Instead of just getting a 200 back, you're going to get a 402, and it's going to tell you where to pay it. Then you pay it, basically, and you can prove payment, and we can get into how you can prove payment, and it gives you a receipt for the payment. And then the third step is now you make the same request you made at the top with the receipt, and it gives you the response. And so that kind of three-step process looks a little bit complicated, but the good thing is that the library kind of abstracts that all away, and you can kind of just do this, and it will start negotiating for you. To use some buzzwords, this is using the blockchain, this is using layers on top of the blockchain and Bitcoin, but there's many ways you can implement it, and the reason why a lot of these implementations are being on Bitcoin is because it's a big network, it's set up, it's somewhat mature for what it does, and so a lot of these things are useful to do on that. So that library that I showed you that did the patching of requests and Flask is called the 2.1 library. You can download it in a bunch of different ways. You can just pipe it to shell, you can pip install it. It's very well documented, so go look at GitHub. It comes with a bunch of modules on it that are all kind of separate. So they have their Bitcoin module, and that's their own handwritten implementation against the protocol. So it's not like they import Bitcoin and things like that. Like Bitcoin is this protocol that you can implement with however you want. And so you can see their implementation, you can see how they announce things to the blockchain. The kind of bit serve and bit requests are the wrappers for Flask and Django. There's Django support as well, and there's requests. So 2.1 is from 21.co. They are a commercial company, but they're kind of, I think, focusing more on the hardware side, and this is kind of a nice piece of open source software that have come out through them. A lot of these transactions you can do from them. They kind of make it a little bit easier to do it from them, but also you can even just use their library to not have anything to do with them and do transactions between people on blockchains or wherever you kind of want. So kind of one service you can do with this as well is this ping test that I was alluding to earlier. Like we kind of want a lot of devices to ping a single server, and we can, in this case actually, so we're the client, and there's actually an aggregator. So rather than having to ask for 1 million devices to ping a server, we can just say, hey, here's to one person, like, hey, here's a payment for 1 million pings. Can you please get 1 million people to ping? And so you just pay one person, they pay all the 1 million, and everyone's happy. And so I really wanted to do a ping test on the census site, but it seemed to not really like it that much. And actually, I was wondering about the legalities of pinging like that, and my friend said, well, as long as you don't point a botnet at it, you'll be safe. And I kind of was like, well, that was the point. So yeah, instead of pinging that, I'm just going to ping my site, mitch.fyi. And so you can see I'm making just once again, the 21 command line thing adds even an extra abstraction layer on that kind of simple Python implementation where you can just kind of do things from the command line. So this one's going to ping my website, and the N in the data is, I'm going to get 7 people to ping my website. I mean, let's go. And then they're going to come back and tell me how they went, what their response time was, what they got. I hope this works. Nope. All right, so apparently, I'm paying 3,000 of these little bits per call. And so if I pinged 7, oh, I know. So you can see here, so I'm paying 3,000 little bits per call, and there's 7, so I want to pay 2,100. And there's a default max price in this call of 10,000, and that's kind of like a safety method, so I don't kind of pay too much. Because the thing is, you set a limit on how much you want to pay, because you don't really know how much you're going to pay until. So let's set max price to whatever, 30,000. All right. The much safer method would have been to just change n to 3 or something, but we like to live dangerously. Come on. Boom, it worked. It worked. All right, so here's like a bunch of, so now it comes back as a list, and these are all the different people that have pinged my server. Look here, someone, oh, it's from Buenos Aires. All around the place, right? And then they kind of like, they pinged it 3 times, that was quite nice, and they kind of are giving me times. Oh, that was a slow one. And stuff like that. So actually I just implemented that thing I showed you of you send you send a payment and you get data back, like there it is. Like, let's not use it in production. Like there's a bunch of caveats and work to be done and stuff. But like there's these new things that are kind of moving in the right direction. So for instance, when I sent this request to the aggregator to do these pings, I actually had to send proof. 1, I had to pay, and 2, I actually had to send proof that I had paid through the Bitcoin blockchain, and it was like this transaction and things like that. But if I couldn't prove that I could pay, like they won't let me do that. So even like simple implementations like work to some extent right now. It's still kind of like a hobbyist kind of thing, but it works. So here's another one, right? So there's a server set up. You can all go to it, I guess. Don't crash it in like 15 minutes. It's storage.mitch.fyi. And you can store stuff on there, and you can read stuff on there, and you can write stuff on there, and it's going to charge you per byte. The pricing isn't good, so I wouldn't actually recommend storing stuff on there per byte. But so a Satoshi is like 1 millionth of a Bitcoin, and so a Satoshi works out to like whatever, 1/100th of a dollar. And so it's basically charging you very, very small amounts per byte, but it can actually meter at that rate. And so if you go to the GitHub thing as well, like there's a full implementation, you can just run it and you can start kind of doing microtransactions for storage as like just a joke thing. And so basically the demo, I've actually screen capped what the demo was because the demo works, but it's a bit unstable to some extent. So if we kind of look in a storage file now, it's empty. And if we look at the client says like, tell us the URL of the storage file on the server, and then tell us where you want to mount that. And so I say like, oh, here's where the files are. And I want to mount it to this /storage file that I just saw. So basically I'm going to create a virtual folder. And so this folder now, when I ping it at the top, now there wasn't stuff in there, now there is stuff in there, files in it. They were the files on the server. And so basically with this, like the top part, the user part is what the user does now, and the bottom part is what's going on in the background. So once the client started, people can just like ls and cat and move things around and just interact with it like just a normal folder on a file system. But underneath what's happening is through HTTP, the client and the server are basically one, negotiating payment and transferring payment, and then also transferring the files. So an ls is the opcode read directory, and that one's free actually. So if you just curled against that, it would send the files back, and kind of the top user layer is the view layer where it shows you like, hey, here's the files. So you can read directory, you can read file attributes kind of, so you can do a stat on it, and the stat is the get attribute of a file. So we're statting on hello world, so it gets attribute of hello world. It kind of gives you the size in bytes of the file. And then, all of these dates are wrong, but hey, 23 bytes, that's great. But then when we try to read the file, if we just try and do a curl with an opcode of read, it returns back this scary looking thing. It returns back a payment required, like we were talking about before. And it also gives you like an address to make the payment. And so if I curl against that, I get a 402 and then I don't know what to do. Patching this requests library means that the client on the background, it gets the 402, it does a put with the payment, and then it gets a receipt from the payment, successfully purchased payment, and I don't have the last line here, but the last line was the third step where now it's got the receipt, now it's going to do the same request it did before with the read opcode, and it's going to get back hello world, and like the hello world spelt wrong, and that's terrible. But it's doing this, so like you can kind of see like 1, 2, 3, 4. That's kind of like the first 4 here, like request / 402, I make a payment, you give me the receipt, and then the last 2 which aren't shown is I now remake the same request I just made with the receipt and I get the response. And then a write file kind of does the same thing. I'm moving the file into storage because you don't want to like live edit the storage files at the moment, it's a disaster. But kind of same thing, like 402, I make the payment, and here actually I see the third part where now that I've made the payment, I do the thing I wanted to do in the first place. I wanted to put on hello world to update it with my receipt, and then ta-da, like I've updated on the server. And kind of here are the 3 parts that matter, like the 402, the payment, and then the re-request with the payment shown. And here's just a thing from the server where I cat the file, and now I can see that the file's fixed from the server, and I updated it from the client. And so, yeah, like this is not anywhere close to there as like, oh, cool, like Internet of Things, micro devices. I have spare data on my phone, like what IoT device wants to like negotiate with me to piggyback the signal, right? Like everyone's talking about connecting to the internet and how hard it is. Like I'll just walk past, and if you just pay me like 1/10 of a cent, like I'll upload a few kilobytes for you. Or I've got storage on my phone. There's all these unutilized devices out there that would be happy to transact basically, but it's just at the moment the friction is just a disaster. Like how would you even do that right now? You'd have to like get an app and you'd put in your credit card and you'd like sign up, and the other IoT devices would sign up, and then like you'd report back to a server and you say like, hey, I did this for this guy, like pay me money. And that's all fine, but just like HTTP, if we could have these open protocols for payment as well, then it kind of potentially could just alleviate all that, where people can just start transacting and sending data and utilizing themselves. There's a lot of things that need to be done though. So for this, you need cheap transaction fees, right? Like if I'm transacting like a millionth of a cent, I can't pay $1. And even things like Bitcoin, which somewhat get the transaction price down, is still like 8 cents. And so that's still way too much, like orders of magnitude too much. There's a lot of very interesting things in this area to lower transaction fees quite dramatically. But that's a really big area that needs to be worked on. The other big thing as well is, okay, now we can prove payment, but how do I prove that you gave me something useful back? So in the example where my phone, say, uses its 3G connection for your data, like, okay, so your IoT device like pays me for the request, and then maybe I can just say, oh, I just got an empty response back. That's what the server told me. And there's really no way of them validating was it actually doing it or not. Like my site, the storage site with reads and writes and stuff, like I don't know, like maybe I'll give you back the file that you wanted to read, but maybe I'll just say anything. And there's not really a lot you can do about it. There's not the point that it's anonymous and trustless. Like you can't complain to someone and get a refund. You can't enforce a lot of things like that. Even like how do you revert a transaction if the server crashes? Because like you saw before, it was this step process where you make a payment and then you show the receipt when you do the request. Like what happens if you make the payment and then the server just crashes? Like right now, there's really no way to recover that money. And so I think on the data side, like being able to, if you could, being able to validate that this data is actually of value, and there's a lot of different ways that you could potentially do that, I think that will really kind of close the loop. And then you can start transacting anonymously in both ways. So I can pay you to store something, and if I could guarantee that you would store that, and if you lost it, say I would get a penalty, that you would be penalized if you couldn't prove that you continued to store it. I think that kind of system really closes the loop and really makes it solid. And there's actually a lot of work being done on those areas of how can you prove certain things. For example, like in the storage area, perhaps, because the thing is like, how do you prove something without disproving the whole thing? So if I want you to do a computation, how do I know that you actually did the computation without actually doing the computation myself? And so through things like hashes and kind of turning problems into those problems where it's easier to verify, either verify the whole output of the transaction or be able to verify certain parts of the transaction. So if I could just inspect like 10% of the calculation, and if that worked out to be correct, then I could probably guarantee the rest was correct, and I'd randomly inspect a part of the calculation. Those kind of things on the data coming back as well is like vital. Like it doesn't work if you can't do that, it doesn't work, because people, like you have to assume bad actors in these situations, and the best response is basically a zero response kind of thing if you're going to get paid either way. And so enforcing it on that side as well is useful. So here's some links. There's the Bitcoin I've linked to protocols, not to the websites, and I think it's, at least from this perspective, it's important because I think that's the thing that kind of matters. Like the Bitcoin protocol, like whatever, the first 4 bytes of the version, and the next is the input, and things like that. And so I think making it this clear thing that Bitcoin or whatever these things are that people implement on, it's not a thing. It's not, you don't download Bitcoin, or you don't need bitcoin.exe or anything like that. There are common implementations that people use, but actually anyone with like a connection that can make HTTP requests or TCP requests can write their own Bitcoin stack. And just like HTTP, they can start speaking in the right way and the network will listen. And I think that in all of this, if anything, like if you can get it that way, that's really useful, because a lot of people can implement in a lot of different ways and make it work for them, and also build on top of that. So you might say that, I don't want it open. I want to actually not make it trustless. I want people to be authorized. Just like HTTP, you can build this walled garden on top of HTTP. Like when I'm using the App Store, it doesn't mean that I think that like this thing of HTTP is useless. I'm still using it, but I can just put my own layer on top of that and do the things I want to do with it. So that's my talk, and that's it.
Questions? Hi, great talk. And I'm just wondering about the whole concept, really, of micropayments and freedom of access on the internet. Isn't it really authorization you want, and not micropayments? You want to allow data to be free, or
That's true. And once again, if people want to have, I'm not saying that every endpoint has to have a micropayment on it. And if people want to have free endpoints, literally free in terms of free money endpoints, that's fine. But if you do want to start putting things on it, a lot of it kind of reminds me of the talk that Nick gave a few talks ago about the Internet of Not Great Things, with how, like, if you're not the customer, then you're the product. And this idea that with Google, let's say, yes, they do sell your services on, you get this thing for free. But actually, even if you wanted to pay very small amounts, you couldn't. There's not infrastructure set up like that. And so with these methods, that there is already economic value being transferred within them, by having a protocol like this, you can now kind of expose that layer, and now it becomes actually open. So you pay for a resource, what that resource is actually worth. You don't get the resource for free and some dodgy dealing goes on in the background. And so, yeah, it's not this thing of that everything's now locked down and you need to be able to pay for everything. It would be for those services that generally are already being paid for in some way, being able to kind of openly transact on them.
Any other questions?
In order to get the cost of transaction down, what kind of stuff, where does that money go at the moment for someone who doesn't know?
The transaction cost?
Yeah, where's that 8 cents?
Yep, so in Bitcoin, where there's a transaction cost, essentially there's a network of people mining. They're kind of working very hard. They're not actually working that hard to process transactions, but they're doing this other thing that basically protects the network from attacks. And so you have to basically incentivize one of those people on the network to basically pick up your transaction and include it in the thing that they're doing. And so at the moment, yeah, it's at 8 cents. There's a bunch of different, like for instance, one thing I'd really, if it at all interests you, is to look at the Lightning paper network, because essentially what it does is it creates these smaller channels. Like let's say Thomas over here, and we're going to transact a lot with each other. Like in the device with the sprinkler and FourCast.io, that sprinkler knows it's going to transact like 10,000 times with FourCast.io over its lifetime. And so if you could say, rather than making 10,000 transactions to the network, if you could somehow aggregate that into one transaction, but still keep it trustless between both the parties, kind of like a bar tab in a trustless manner, then you only need to do one transaction to the network, and now you've just reduced the transaction cost by 10,000-fold without actually having to reduce the transaction cost. So there's a lot of different ways at it, and I think that, yeah, like getting that transaction cost down to almost zero is will be good if it can be done.
Would you see a case where you might sort of top up your sprinkler with credit, so it's allowed to, it may not have anything to offer, but it may need to access services that...
Yeah, I think that's a perfect example. The way I like to think of it is these Net Zero things where the devices can provide service to the other things. And even if they do have something that's a very, very low service, like I said in the ping service that it was 10 times less, maybe it's 1,000,000 times less. And so the sprinkler has to do 1,000,000 pings to get a single request. It's probably not doing much, so maybe it wants to do that. But yeah, to your case, yeah, maybe you just put 2 cents on it and it's fine for life. And even right now with a current implementation, there'd be a really easy way of doing that without having to directly, you wouldn't have to connect to the device to do that. But yeah, you can put 2 cents on it as well, and you're good to go forever.
I've got a question for you. Do you want to make any comments on sort of what's been going on some of the currencies,
Yep.
and whether you think that the current currencies are the ones likely to work in this kind of system, or whether you think new currencies are likely to emerge?
Cool. So just quickly, the second biggest currency, Ethereum, had a thing called the DAO. And Ethereum does these things with smart contracts and Bitcoin slightly does this as well, where you're not actually doing just data transfers, you also can put logic in the code. And so before, when I was talking about how can you only give the payment if I get a good response back, you can kind of implement that in Ethereum where you implement the logic beforehand, and then you can the logic settles the arrangement. And there was a problem, $70 million went into this contract that just a program controlled, and there was a bug in the code. And so, and the thing about these contracts is they're trustless and they're foolproof and they're immutable. And once you write it, it's set in stone. It's like law. That's the reason it was there. And so, there was a bug in the code and someone got away with all the money and and things like that. And so they did an interesting thing where they actually forked their ledger, their kind of blockchain, their status. So if you had 1 Ether one day, you actually had 2 Ether the next day on 2 different chains and these 2 different networks. And now there's Ethereum Classic and there's Ethereum, and they're both still running and they both still have a price. So there's a lot of interesting things happening in this field and a lot of lessons being learned. And this was a $70 million lesson that was being learned. But I'd say that this probably, I think, say the bigger protocols are to some extent maturing. I know I just explained a story that doesn't sound like that, but they're learning lessons and they're growing. And I think that they're moving very quickly in trying things like this idea of this contract that owns $70 million. I think that's one way to go about it. I think you'll get good results. I think it won't look great at the start. There's going to be many, many more mistakes made. But yeah, I think that there's good progress being made, and that with payment layers, even potentially more than just data requests, you don't want these bugs later on. You want to iron them out now. And so when these big mistakes happen, to some extent, it's quite nice they're happening now when it's still it's $70 million, but it's not do or die yet. And so there is some time to kind of make these mistakes and learn these lessons the hard way. And I'm sure there's going to be much less bug. Everyone's taking a step back now and they're like, oh, we were way too free and easy with these contracts. And now these contracts are going to get way better and not have these bugs. So I'm cautiously optimistic, and it'll be a very interesting ride with all the things they're trying to implement. But I think progress is good, and if you want to do it fast and make mistakes, that's fine. And if you want to be cautious, that's fine too, and the best method will win out.
Great. Oh, one more question.
Thank you. Not so much a direct question as more of what do you think of where this may lead, where we have microtransactions where devices are incentivized to provide data. So they have a sensor and they can provide that to the network because the weather station wants to know if it's raining. What's going to happen when we have all of these devices packed with lots and lots of different sensors that they want to sell to the network for whatever company may wish to purchase it? Is this going to cause some interesting supply-demand kind of thing, or do you have any thoughts on this? Have you read any papers or where this may go? I
haven't read any papers. I just kind of make things up. But if the things that have we price goods for a reason in the market. It does, and we can say things about capitalism, and it doesn't distribute resources that fairly. But it does a better job than perhaps some other ways of distributing resources. And so to say that you start going down and down in the price of goods and then you get to this threshold where you go, oh, actually it doesn't matter anymore. All these things we had for markets that mattered when a thing was $1, now it doesn't matter anymore because it's 1/100th of a cent. The magnitude doesn't matter as much, but those effects still hold. And so, yeah, I think that with supply and demand, and if there's too many sensors in a region, then the market's going to deem the price per sensing low. And so potentially, say, the sensors in the region, the ones that get the best sensing data will probably be the ones that are preferred. Or with the FourCast IO, if they are getting DDoSed, rather than just having a flat rate limiting and just saying to everyone, no, you're all requesting too much, everyone stop, just with the dynamic price. And so, I work for a POS and we do battery control. And just seeing it respond to price signals in the market, we look at the energy price, and energy is a dynamic price. And looking at it respond to those price signals in the market, if you model the situation well and just give it an optimization function, in some circumstances, like devices can do amazing things. And so even a sprinkler, you might say like, who cares about it responding to a price signal? Well, one, if there's a billion sprinklers, everyone cares. But to implement it to respond, you could just say a simple thing like, you know, I need you to get a reading from FourCast.io between, say, 5 a.m. and 8 a.m., and that'll be my morning prediction, and between like 9 p.m. and midnight, and try and minimize cost, and just assume the cost for today, the dynamic cost of FourCast.io, will be the cost from yesterday. And even as simple, and they can't all do that because then you'll get oscillations and it'll be terrible. But even a simple implementation like that, right, which is very easy to write, it's very low computationally. If you have a not insignificant amount of devices in a market doing that, then you start to get some quite nice demand response to the price signaling. And now FourCast.io never need to shut off servers, they never need to rate limit anyone, they can just adjust their price based on who wants it. And the network of devices can adjust like globally in this way that it almost looks like they're cooperating, just like a normal market. But.
Great. Please thank Mitch for his talk.